Hi, I'm Matti Lehtinen from the National Public Health Institute of Finland and Karolinska Institute, Sweden. I'm today going to talk about impact and resilience of different human papillomavirus vaccination strategies, which is, of course, in the heart of this WHO elimination campaign. Now that we know that HPV vaccines protect against invasive cancer, which was the original intention of our population-based studies to show this in a randomized setting. It was later shown in Sweden based on an observational basis. Now that we know that both the bivalent and quadrivalent vaccines indeed protect against invasive HPV-associated cancers, the question is what to do with this vaccine. This vaccine is inducing sustainable protection against infections and due to the sustainable antibody response that it is inducing. But what to do? The comparison is actually not between vaccines. Which vaccine to use is a wrong question. The question is which strategy. And this is especially because the coverage of girls-only vaccination program, the early programs in the affluent countries, has been moderate at best. And if we have a look at the worldwide coverage, only in the affluent countries, high-income countries, it's 40%, but in no country, except for few exceptions, it is above 50%. And this is way too low for elimination campaign. And thus the question is not so much how to increase vaccination coverage among girls, but how to identify the best vaccination strategy. Girls-only vaccination will never lead to eradication of oncogenic papillomaviruses, and the elimination threshold for incidence of 4 cervical cancer cases in 100,000 women years, that was actually achieved in Finland in the late 70s by mere cervical screening. This threshold is very fragile and subject to changes in risk-taking sexual behavior that took place in all Western countries and are taking place all over the world, and resulted in first in the epidemic of HPV-16 infection in Finland, and 10 years later epidemic increase of cervical cancer in fertile-aged Finnish women, the epidemic that is still ongoing. So the question is what to do to tackle this epidemic. And if we start from the epidemiological data, we can see easily that this is due to changes in sexual risk-taking behavior. The number of sexual partners has more than tripled in Finland during 40 years, and this is true also for the other Western countries. Mean age at sexual debut has been coming down, but not so much in the latest years, while the epidemic of cervical cancer is still ongoing. This is also true for active smoking. That cannot be the reason for cervical cancer epidemic in fertile-aged women. The reason most likely is increase in the incidence of HPV-16 infection from the 80s to 90s. The increase is tremendous, more than twofold in young adult women in the southwestern Finland, which corresponds to the increase of cervical cancer incidence 10 years later. So we started to contemplate what would be the method of identifying the best strategy against HPV epidemic and also cervical cancer epidemic, and the question was whether we could run a community randomized trial in Finland. The community randomization was done among the middle-sized Finnish towns with more than 35,000 inhabitants. There are 34 such towns in Finland outside the Helsinki metropolitan area, and the important thing was that these towns were 50 kilometers apart from each other to prevent contamination from adjacent towns with different vaccination strategies. We were using gender-neutral vaccination strategy in the intervention arm A communities, girls-only vaccination strategy in the intervention arm B communities, and hepatitis B vaccination was given in the control C communities. The vaccination coverage was sort of set at 70%, which was later on in the trial not achieved, but power calculations were based on this coverage estimate. In addition, we were careful to include also non-papillomavirus vaccinated vaccine recipients in the A and B communities by randomization for vaccine. 90% of girls and boys in the gender-neutral arm were getting papillomavirus vaccine, 10% in the gender-neutral arm, and in the girls-only arm were receiving hepatitis B vaccination. One important thing in the power of this kind of community randomized trial was also the heterogeneity between the different arms, and we had a possibility to look for cumulative incidence, which as HPV-16-18 seroprevalence in the different 33 communities, and based on this we could put into different arms comparable towns with high, moderate or low seroprevalence for 16-18 antibodies, and this resulted in very high or at least ample statistical power, 80% power, for comparison of HPV-16-18 prevalence reduction in the end of the trial in the gender-neutral versus control communities or girls-only versus control communities, and also the interim analyses were powered. And this was very, very important and resulted from the reduction of heterogeneity between communities. What we managed to do in this community randomized trial, arm by arm, was that we were able to enroll equal numbers of vaccinated 50% of girls, both in the first two birth cohorts and in the last 94-95 born birth cohorts, and 20 to 30% of boys in the different arms to this vaccination trial. The endpoint questions or objectives were reduction of HPV prevalence in vaccinated girls, which was providing estimates for vaccine efficacy, reduction of HPV prevalence in unvaccinated girls in the different communities, which was the basis for analysis of herd effect, and the weighted estimate of overall impact of vaccination strategy in 18-year-old girls, which was the co-primary endpoint of the trial, gender neutral versus control, girls only versus control. And really to elaborate the comparisons that we were making, it is important to understand that the protective effectiveness was weighted between the arms by vaccination coverage in the arms, and luckily the vaccination coverage as such was comparable between A, B, and C communities. And as mentioned in the previous slide, the protective effectiveness was a weighted estimate of herd effect and vaccine efficacy in respectively in unvaccinated and vaccinated girls. About the method of looking for the HPV prevalence reduction, in the first place we were using HPV DNA typing with a multi-dose mass spectrometry based high throughput analysis looking for prevalence of a number of vaccine covered and other genital HPV types. And the most important result was for HPV 18, 31, 33 prevalence reduction that we saw happening by birth cohort from the first to the last birth cohort in a statistically significant manner, but only in gender neutral arm. This was not observed in the girls only arm or in the control arm. And the overall protection against HPV 18, 31, 33, 35 was also observed, especially in the gender neutral communities within 2 years, comparing the 92, 93 and 94, 95 birth cohorts in the AMP figures. Here the black circle is showing the gender-neutral communities that show remarkable reduction of HPV prevalence, but not for HPV 16. And the HPV 16 issue we were tackling with another method of looking for the prevalence. We were using HPV 16 and 18 antibody detection and looking for the antibodies in a population-based Finnish maternity cohort that has been collecting all serum samples from pregnant Finnish women since 1983. We were taking a randomized sample of the Finnish maternity cohort sample donors from the pre-vaccination era and post-vaccination era, covering a period of 30 years. And by community, this was done using the HPV serology, antibodies binding to HPV 16-18 pseudovariants. We were also looking for altogether 17 different HPV types, antibodies to those, and detecting herpes simplex virus type 2 antibodies to be able to stratify the analysis by risk-taking sexual behavior, herpes simplex virus type 2 antibody positivity being an indicator of sexual risk-taking behavior. And what we observed was that this vaccination coverage in the post-vaccination period was increasing in the vaccination, gender-neutral girls-only vaccination communities up to 30%, because this was overall population of young and adolescent women, a remarkable proportion of whom participated the vaccination trial. In the control communities, the proportions of vaccinated participating, for instance, in the national vaccination program from the beginning of 2014 were negligible. The important observation, was that we could confirm reduction of HPV 16 and HPV 18 seroprevalence in the arm A communities, that is gender-neutral communities, and that this was not seen and that there was a statistically significant difference between gender-neutral communities versus control communities, but also versus girls-only communities. And we were able to use the Public Health Institute model created by Dr. Simo-Pekka Vänskä to ensure that over time the gender-neutral vaccination is able to eradicate HPV 16 from the gender-neutral vaccination communities from the new birth cohorts in 30 years, which is remarkably better than predicted from the old models for girls-only vaccination. The gender-neutral vaccination is also more resilient than girls-only vaccination over time, ensuring that the reduction is stable. The effect of vaccination in unvaccinated women has been observed also in Netherlands, where people have been looking for unvaccinated women effect on HPV-16, HPV-18 prevalence, but this is not randomized trial data, however reassuring that our observations have been confirmed also elsewhere. We were able to continue our population-based study looking for samples that were obtained in a screening trial that was continuing the vaccination trial in 22, 25, 28-year-old women participating in the original community randomized trial. And the participation was showing compliance to the trial, which is important here in the long run, looking for instance for type replacement. What we observed already within 8 years at age 22 was that the ecological niche occupied originally by vaccine covered types 16, 18, 31, 45 was emptied by both gender neutral and girls only vaccinations, shown here in yellow and blue. And the important observation was that the niche was occupied by non-vaccine types, and really this continued to result in equal numbers of high-grade SIL lesions in the different vaccination arms. However, with questionable progression potential in the high-grade SIL lesions in the vaccination arm participants. This has been elaborated in the other lecture that I'm giving during this lecture series on triage of HPV associated lesions in vaccinated women. So some reflections. Screening is not a reliable method to tackle epidemics of oncogenic HPV infections or the outcomes cervical cancer most notably. Vaccination provides sustainable immunity and protection against invasive cancers in vaccinated individuals. But as for the unvaccinated individuals, the egalitarian birth cohort-wise herd effect can be achieved by gender-neutral vaccination already in less than 5 years, and will lead to eradication of important high-risk HPV types in 25 years. HPV types not covered by the vaccines are fulfilling the vacated ecological niche, but this may not be serious as for cervical cancer elimination. Thank you.